Today we're going to start looking at roots and radicals. And we have a brief introduction here to get you ready for what these actually mean and how we'll be using them. So first we're looking at, as you can see, the square roots. And square roots come from squares, actually. If we look at the dimensions of squares, and I have that this side is A, then we know the other side is A. And when we find the area of this square, we have A squared. The reverse of this would be, I know the area is A squared, tell me what each side is. And to find each side, we take the square root of A squared, which is A. So we know 4 is 2 times 2. Therefore, the square root of 4 is the square root of 2 times 2, and we just get 2. 25 is 5 times 5. So the square root of 25, or 5 times 5, is just 5. And here's our A squared example. A squared is A times A, and the square root of A squared is A. So I like to tell kids when you have two of the same factor, remember factors are the things that are multiplying together. Two of the same factor under a radical gives you that single factor on the outside. So when in doubt, you can always break them down. Cube roots come from a cube. So if I label my 3 edges of this cube, I'll use X this time. The face, X by X, is a square, and the depth as well is X. So the volume of this cube is X times X times X, or X cubed. And taking the backwards of that, right? If I want to know each dimension of a cube when I know the volume, then I can take the cubed root of the volume and just get each dimension or each side. So notice a couple things. These match, and we get a single out. There would be 3 of these. 3 of them under a cube root, and I get that term out. Here in the square root, it's really an invisible 2 there, so these match, and we get that side length from that. So keeping that in mind, if you know 2 times 2 times 2 is 8, then the cubed root of 8, I have 3 of the same factor. I need 3 of the same factor now to get that factor out. 3 times 3 times 3 is 27. So the cubed root of 3 brings that 3 out. X times X times X is X cubed. 3 of the same factor, and it brings that X out. So the cubed root of 64, well, maybe 64 is something special. You might try something on your calculator, pause a minute, see if you get it. 64 actually breaks down into 4 times 4 times 4. So indeed we get 4. Well, we can keep going with the roots. There's just not square roots and cubed roots. There's 4th roots and 5th roots. Lions and tigers and bears, oh my. So 4th roots, I can only bring out a term or a factor if I have 4 of the same term. So 2 times 2 times 2, there's 4 of the same term. They give us 16. So the 4th root of 16 is 2. 3 times 3 times 3 times 3. 3 times 3 times 3 times 3 is 81. So the fourth root of 81, I'll write this one out, same as the fourth root of 3 times 3 times 3 times 3. We just get 3. How about the fourth root of m to the fourth? Just m. So our roots can get much bigger. Now let's point out a couple of vocabulary terms. The number that we're tucking in there in the radical is called the index. And the expression under the radical is called the radicand. It's the index that we will talk about most often because that's what's controlling how many of each factor we need to bring that factor out. All right, calculator, our favorite thing. We can use the calculator to help us do some problems. So we're going to go to our calculator and we're going to check out a couple of different examples. Fourth root of 81, we're going to get from typing in 4, math, 5, and then 81. So let's go see what that does on our graphing calculator. And I'm going to clear out some things first so that everything doesn't look like a mess. Clear this from last time. Okay, and go to my home screen. So we said we wanted to try the fourth root of 81. So we need to put the 4 in first. I forget that often, but you'll know once you get to the rest. Then the math button. And then look at our menu here. We want to choose number 5. Let me just go down to number 5 and talk about it. It says the xth root. So we already put in the 4. So we want to do the xth root. So we're going to choose that one. Xth root of, and we can put in our 81. And enter. And the xth root of 81. The fourth root of 81 is 3. Let's try the next one. It says we want the cubed root of 64. Now, I could do that the same as the top one with a 3, math, 5, 64. But in the math menu, you may have noticed there's a cubed root right at number 4. Whoops, let me go back to that. Let me hit clear. Math, cubed root is number 4. There it is. So I can do a cubed root right on my calculator, and let's put in 64 and enter. And you're good. So your calculator can help you do some problems. I hope you won't need it for most of them, but in the case that you're stuck, you can always go and give it a try. So this gave us 3, and this gave us 4. Don't let those higher roots scare you. So let's do a few here. Let's take a look at some of these problems at the bottom of our page. First, we have the cubed root of negative 8. So is there something times itself 3 times that gives us negative 8? Well, negative 2 times negative 2 times negative 2 is negative 8. So my answer is negative 2. The second example has a negative in front of it, the square root of 25. So that's pretty simple. I know that 25 is 5 times 5, so it's negative 5. The negative simply negates your answer. A to the 8th. Now, that means A times itself 8 times. And here we have a square root. So our index is a 2. It's invisible. So every 2 A's can come out. Well, here's 2 A's. Here's 2 A's. Here's 2 A's, bring 1 out. Here's 2 A's, bring 1 out. So what do we have? A to the 4th power. Nice. All right, mixing up my colors here. How about 0.09? The square root of 0.09. Well, 0.3 times 0.3 gives me 0.09. So my answer for square root, I've got 2 of a kind. 2 of a kind brings 1 out. Square root of 36 over 25. Okay. 36 is 6 times 6. Remember, I'm looking for pairs with my index of 2. 5 times 5. So this is nice. We get a 6 on the top and a 5 on the bottom. Could also split these up. You'll see this in another lesson as separate radicals. Cubed root of 81. Let's try that separate radical trick here. Cubed root of 81 over the cubed root of a cubed. Give myself a little room. Let's see, don't forget that index because now it's different. 81, I think we use that one up above. Let's see, it breaks down into 3 times 3 times 3 times 3. So there's a lot of 3's there. A cubed is A times A times A. Cubed root means I need 3 of a kind to bring 1 out. Here's 3 of a kind. I'll bring 1 out. On the bottom, I have 3 of a kind, so I'll bring A out. But what do I do with this guy? He didn't get to come out. Well, you leave it in its radical. So that answer is 3 cubed root of 3 all over A. We've got a couple more on the next page. If there's a positive or negative in front of it, leave that there. Positive or negative, square root of 100, kiddos, is 10. 81, x to the 4th, square root. So I know if I break this down, 9 times 9, x, 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 x. Pairs come out. A 9 comes out. X comes out. Another x comes out. And there we go. Ooh, look at the next one. 5th root. 5th root. So I need 5 of a kind. Let's think about 32 in the form of a factor tree. 32 breaks down. Let's see, I know that it's 8 times 4. 8 is 4 times 2. 4, 2 times 2. Go all the way down to the primes. Prime factorization. So what I can see here is that 32, where I began, is the same as 2 times 2 times 2 times 2 times 2. Pretty cool. Well, how many are there? 5 of them. So they're going to come out. And y to the 5th, I hope you know there's 5 of them, so that comes out as well. Okay. Whew. Let's take a little break from that and look at, are these rational, irrational, or neither? So remember, rational is everything you can write as A over B. Irrational are your nit nerds from yesterday. And neither, well, who knows what that is? Let's see. Square root of 10. Give you a minute. Irrational. If you put it in your calculator, it is a decimal that doesn't repeat and does not stop. Cubed root of negative 27. Well, a little thinking. It's negative 3 times negative 3 times negative 3, negative 27. So that equals negative 3. That's a nice little number. Rational. Square root of negative 4. Have we ever had a negative under a radical? Can you think of a number times itself that gives you negative 4? Nope. So this is the one. These are neither. So if it's not rational and it's not irrational, we know it's not real. And not real means it's neither of those two. Last example here, the negative's on the outside. Okay, so that's negative square root of 9, which is 3. And negative 3 is rational or irrational? Rational. Okay? So we had an irrational, a rational, a neither, and a rational. All right. Last couple parts here. This says determine the set of numbers for which the given radical is real. So what we don't want negative, or we don't want negative values under the radical. We just saw that one that was not real. We want it to be real. So what we do want under our radicals, we want the expression under the radical to be, well, not negative, is to be greater than or equal to 0. Oops, I'm spelling it with an or. Greater than or equal to 0. That would be positive. So with that in mind, if we do this algebraically, these are real easy. I want what's under the radical to be greater than or equal to 0. Okay, I'm going to sound like a broken record. I want what's under the radical to be greater than or equal to 0. What's under the radical to be greater than or equal to 0? What's under the radical to be greater than or equal to 0? So pause for a moment, solve all these, and tell me the set of numbers that work. So I hope you're checking now. This set of numbers, any x that goes in there that's greater than or equal to 3 will work. For example, I could do, what's bigger than 3? How about 4? 4 minus the square root of 3, that's good. Square root of 1 is 1. Here, had a little flipping issue, had to flip my inequality when I divided by negative 4. So any number less than or equal to 2, I'll try 0. Square root of 8 minus 4 times 0. Square root of 8. That's good. That's fine. Here, all my x's need to be greater than or equal to 3. Let's try 10. Square root of 30, take away 9. That's awesome. Square root of 21. We can do that. That's a real number. It's irrational, but it's real. And the last one, my x's need to be less than or equal to 5. So let's test, what do you want to test? Let's test 1. That's less than or equal to 5. So square root of 5 minus 1 is square root of 4. That's real. Okay, So that's our set of numbers for which the given radical would be real. Think how we started. Take what's under the radical, make it greater than or equal to 0. Okay, last section. Consider two different methods to solve these two types of equations. All right, I'll do each of these two different ways. The first way, notice all we have is the squared term in each case and a number. Squared term and a number. So that's important to notice. In this first one, I can square root both sides to solve for x. What I'm going to need you to remember here is if you square root, then you have to put a plus and minus. So I need a plus and minus right there. Makes all the difference in the world. So my x's are plus and minus 6. All right? In this second example, I would have to add the 81 over to get it into that form. Square root both sides. Oh, I'm square rooting, so I have to put a plus minus. You square root, you plus minus. And so a is positive or negative 9. The other way to solve these, if you're still listening, okay, there we go. The other way to solve them is to, here's the original, get it equal to 0. So I'm going to subtract 36 over, and now I've got dots. And there's the same two answers. Here, the original was already set up for us. You might have seen, hey, I've got dots. A and A, 9 and 9, plus and minus. Woohoo! So A is negative 9 and A is positive 9. Same two answers, just different methods of solving. All right, see you tomorrow.